Okay, hey Mackenzie and Aiden. This is 3-4. We're going to start notes for this section. And I'm going to skip over top of a lot of this and just briefly go through it just because I feel like we've done a lot of this stuff before. But we'll go through these graphs up here at the top just as a review. This guy right here, these are all polynomial functions, by the way. Polynomials are like curvy guys, right? So like stuff that has curves and stuff. This guy is... Oh, we've talked about stuff that's not polynomials. Maybe let's talk about that. Not polys. What's an example of something that's not a polynomial function? We have polynomial functions,
Something
which
that
are these guys
doesn't
here.
pass the vertical line test? Is that what you're asking?
Could be. I mean, yeah, sure. But they could pass the vertical line test, and it's like, what about this guy? He is an absolute value function. He's not a polynomial. Or like this guy, not a polynomial function. He's a rational function. He's like the boomerangy guys. Or like this guy. He's not a polynomial function, right? Okay. So those are not polynomials. There's more than that. There's like, we could go 2 to the x power, which is an exponential function. Log functions are not polynomials, whatever. So a bunch of those are not polynomials. This list could keep going. But polynomials are going to be these ones down here. So like x to the first power, x to the oh, they don't even have an x to the second power. Yeah, they do. Over here. X to the third power, x to the fourth power, x to the fifth power, x to the sixth power. Why do they not go in order?
What do you mean?
Like, here's x to the first, here's x to the second, here's x to the third, fourth, fifth, sixth. Why do they not go in order? I know why they don't.
Who's third line?
Put a little line down the center of your page right here, in the middle. These guys on the left are all x to the odd powers, right? X to an odd power. And all of the x to the odd powers behave a certain way. This guy is a linear function, right? Linear, if you want to write linear on there, okay? And he starts and ends in opposite directions. Same thing with x to the third power, which is a cubic function. Starts and ends in opposite directions. X to the fifth power is a quintic function. Starts and ends in opposite directions, okay? These are all x to the even powers, and those are all going to end in the same direction. So up and up, up and up, up and up. Do they always end up and up, though?
Yeah, if they're even, maybe.
If they're even, do they always end up and up? What if it's like negative x squared? Then
Down and down.
he will end down and down. If he's negative x to the fourth power,
Same direction.
he ends down and down. So even just means same direction. Okay? Odd means opposite direction. This one, like the odd ones over here, all these ones over here, start in the bottom left and end in the top right. Start in the bottom left, end in the top right. Do they ever go the other direction? Or when do they go the other direction? Do they ever start up here and end down here? Or start up here and end down here? Or start up here and end down here? Does that ever happen? When they're negative, right? So negative x squared, or negative x would be this. Negative x cubed would be this. Negative x to the fourth power, or fifth power would be that, whatever. Now, sometimes you will have like humps and bumps inside of here. So if this is x to the fourth plus, like, don't write this down. X to the fourth plus 2x cubed minus 7x, whatever. If it has more than that, sometimes he'll be a w, right? And he'll have humpy and bumpy stuff. Same thing with x to the sixth. If he has more stuff after him, he will have like maybe like 3 humps, right? So just so you know, sometimes that's a thing. Okay? All right, moving on. Let's go to, these have to do with the transformations. Okay, so like to the left and down and whatever. Okay, so go to example 1. Let's just do this. Graph each polynomial function. So we're going to do each one of these the same kind of way-ish. ABC. Let's talk about what the parent function is. I'll write out the word parent. Parent function. And then let's talk about the transformation. I won't write that out every time. Okay, so if I'm looking at A, what's his parent function? Like, what's his starting function?
X to the fifth.
X to the fifth. Okay, and what's the minus 2 do?
Down to.
Down 2. Okay, so if I go to graph him, x to the fifth is going to go opposite directions. He's going to look kind of like an x cubed, like that. But he's going to be down 2, so I'm going to go down 2, and I'm going to go like this. That's what he will look like. He's kind of wider in the middle than an x cubed would be. Sometimes he will have humps and bumps if he has like more x's inside of here, right? Like if he has an x to the 4th, x to the 3rd, blah, 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 all the things, right? Okay.
So he has to hit 2 on both of them?
No, just on the y-axis. I don't know where he hits over here. I don't know.
Okay.
Not necessarily true that he hits 2 over there. Okay, this guy, what's his parent function?
X to the 6.
X to the 6th. What does the 1 do?
It's a left
To the left 1, right? Because it's plus 1. Okay. X to the 6th without any other x's involved in there. It just looks like a flat tire guy. If you look up here, this is x to the 6th. He looks like a really flat tire x squared with a really flat tire. So I have that guy, but all I'm doing is moving him to the left 1. So I'm going to go left 1, and his flat tire is going to look like this. He's going to be like a really wide parabola. Now, he will be like an M or a W with a bunch of humpy and bumpy things, whatever, if you have plus blah, blah, blah after it, right? Like if I had plus x squared, plus 7x, plus blah, 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 whatever. Okay, third one, C, has a lot of things. What's his parent?
X to the 3rd.
X to the 3rd. If you strip away everything else. How many things does he have happening to him?
3. 4, because over that y.
4. The negative, the 2, the minus 1, and the plus 3. Okay, now, so I'm going to make a list of 4. 1, 2, 3, 4. If I do that, which one of those comes first?
The right one.
Yeah, negative 1. So he's going to the right 1. Okay, which one's going to come next?
The 2. The negative.
The 2 and the negative are happening at the same time, so you could technically switch these 2 around and it doesn't matter. Which one do you want to do first? The 2. Let's do the 2. Okay, the 2 is going to
Vertically compress, stretch.
vertically stretch by 2. We're multiplying him by 2, which makes him 2 taller, right? Like twice as tall.
Over
Vertical
the
stretch by
X
2. The negative is over the x, you're right.
And up
And the
3.
plus 3 is up 3. Up 3. Ooh. Okay. All right. I'm going to write out here what normally x cubed looks like. I'm going to do it right here. This is normally what x cubed looks like. Okay, he's like a parabola, but like half of it's down. So this is normal x cubed right here. All right, I'm going to pick on this vertex point right here. Okay, so instead of that being at 0, 0, we're going to the right 1. Okay, we're vertically stretching him by 2, which is going to make him taller. We're flipping him, and then we're going to up 3. 1, 2, 3. So his vertex will be right here. Okay, when I go to graph him, he's going to be taller, and he's flipped.
So he's going to go like this.
So he's going to go like this, and he's going to be tall. There you go. Something of that nature. And I'm not going to be real picky. Just as long as you get the vertex in the right spot. So the right 1 and the up 3 are going to be what moves that vertex. The other guys are just like taller and flipped. Okay? Good? And we kind of know all those rules, right? Oh, gosh. Determine the largest open interval of the domain for which each function is increasing or decreasing.
What's that mean?
All right. Oh, this is not going to be too bad. They want us to tell where he's increasing. So like this function, A. Let's go back here. We have increasing and decreasing. So when we judge increasing, decreasing, we're going from left to right. If we're going from left to right, where is he increasing?
From 0 on.
Okay, so 0 is right here. You're saying from 0 this way, he's going up. What about over here? We're going from left to right. He's caving downward, right? But he's still increasing,
Always increasing?
right? He's increasing from negative infinity to positive infinity, right? Like if I start my car over here, I'm going uphill no matter what, right? Yeah? Decreasing? Nah. Okay, the second one, increasing and decreasing. Okay, this point right here, we want left 1, by the way, so this is at negative 1 comma 0. So he is doing what first?
Decreasing.
He's decreasing, like he's going downhill first, and from negative infinity until he gets to
0.
no
1.
negative 1, because we're going to x coordinates, right? And then as soon as he gets to negative 1 on the x-axis, he starts and he turns around and he is increasing from -1 to infinity. Increasing. Okay, am I going too fast?
No.
Okay, this guy, what's he doing? Increasing, decreasing.
Always decreasing.
He's always decreasing no matter what. Like the whole way through, he's going down, right? He's never increasing. He's decreasing from -infinity to +infinity. Okay? Good. Maybe. Okay. Dun, 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 dun. Okay, we already talked about like an odd degree and an even degree and all of the things and whatever else. Okay. Let's go to example 2. Oh, okay. All right, they just want us to, on example 2, to match the graphs. So let's look at the parent function for graphs. F. X to the 4th power. What does x to the 4th power look like?
Same way.
Same direction. And is he going to go up or down? Up. So I have no idea what he looks like, but maybe I know he goes up and up, right? What about h right below that? He's x to the 3rd power.
So that one has to be C.
Oh, that one has to be c.
Right? He's the only one going up and up.
This one has to be c. Do we agree with that? Yep, I think so. H, this is an x to the 3rd power.
So each way.
He's going to go opposite ways, but which way is he starting first?
Like a B.
He's starting down and ending up, right? That would be positive 3x to the 3rd. So he's going to be like B. Do we agree with that? Yeah? G is a negative x to the 6th power. So he's going the same direction, but he's going down. I have no idea how many humps and bumps he has.
Like an A.
And he looks like an A. Okay? And K is a negative x to the 7th power, which means I know he goes opposite directions, but he's going downhill from left to right. So he's starting up here and ending down here somehow.
D.
And that looks like D. Do we see how that works? Like the odd or even, and then the positive or negative tells you which way he goes. Yeah. Okay.
You should give us lots of those.
I should give it, yeah. There's there's a bunch of them that are matching on here. Okay, let's do a couple of these and then we'll stop here quick. Actually, I want to do example 4 before I do example 3. Can we do that? Yeah, let's do example 4 before we do example 3. Okay, example 4 is already broken down for us. Okay, all right, now here's the deal. If I were to multiply all these guys together, what would the degree of the parent function be? He would be an x to the what?
3rd.
You sure? What?
Oh.
4.
Yeah.
He would be 4, right? Because like this guy squared means that there's just another x plus 2, right? So if I would FOIL those all out, he would end up being an x to the 4th power function. Okay, which means he's going to cross up to 4 times, all right? And I can find where he crosses, okay? The places where he crosses are at these 4 places, okay?
Positive 1.
If I set this equal to 0, he'll be at positive 1, you're right. If I set this guy equal to 0, he will be at positive 3.
What about the negative outside?
That's going to make him go down like this. Yeah, that's a good thought. That's a good thought. Maybe we should address that first. So instead of him being a W, he's going to go like this instead, okay? But it won't change your zeros. You don't have to worry about that,
He's gonna be
okay?
an M.
This guy right here, x plus 2, is going to change him to be minus 2, and then I have another x plus 2, so I have another minus 2. Now, the fact that these two, there's 2 of them, means he has multiplicity of 2. What happens when he has multiplicity of 2?
Touch.
He touches that point, but he's not going to cross. Touch, not cross, okay? These guys
We're gonna cross.
are going to cross here, and it's going to cross here. Does that make sense? So I can kind of figure out what this thing's going to look like. They want us to graph this thing. Okay. Now, I'm not going to be able to graph him exactly because I don't know how high his humps and bumps go, but I can kind of figure out. Okay, so -2 is one of his spots. +1 is one of his spots. And +3 is one of its spots. Okay? And I know, because of that negative, that he starts down and he ends down. Okay? And he's going to cross here, he's going to cross here, and he's going to touch here. Okay? Can you kind of see what this is going to look like?
This is what mine looks like, right? Because it doesn't matter, right?
Oh, wait, I have that wrong, labeled. He's going to touch here, cross here,
Yeah. Okay.
cross here. Yeah, because you had it right.
That's fine.
Okay, so he starts down here, I know for sure. He's going to come up and touch, but he's not going to go cross, so he's going to come back down. I have no idea how far he goes down. I don't know. Whatever. But he's going to turn around, come back up. He's going to cross through. He's going to cross through again. Again, I don't know how high that goes, but that doesn't really matter. We're just trying to do a rough sketch of him, and he's going to end down. Got it? And I gathered all that information in about 5 seconds from like what he looks like, right? From him already broken down. Woo! Okay? Good? Shall we do one more? Or should we save it? Save it?
Yes.
Okay, I'll go copy your homework assignment. So we got to do example 3 tomorrow,
And then the
and 5 and 8. Because I skipped 6 and 7, and I remember why we skipped 6 and 7, because I don't like them. Okay, goodbye, girls.